Good morning. I have to go grab my coffee. I'll be right back. Okay. I am with coffee. The coffee is with me. I and the coffee are one. Yes. Hey, Stunt. And Phil. All in winter. Welcome back. So, I got AST graph goodness. Except I just broke it. What happened with the taskbar? I'm not sure I follow. Alright, what did I break? To do this. That's not good. That is so weird. Why is it doing that? Is it this? Hey, Raul Rita. I wonder. I might have broke that. Yeah, I think I did. Oops. Wrong one. Helps if you call the right method. Hey, Soding. Soding, you are so beyond... You're much better than a tokenizer. I gotta think of a good name, but it's better than tokenizer. There you go. No, you... Soding is the universalator. There you go. All right, that looks much better. Okay, so we've got graph. Yay. So I've been fixing small little bugs here and there. But we've got our module, we've got the root block, we've got the root scope, we've got all of our statements, and then the things that the expressions they point at. We've got our binary operators. And yeah, so far everything looks pretty good. Yeah, it's getting there. I had refactored this because, so even though their documentation tells you it's deprecated and you should use their HTML formatting, their HTML formatting is a pain in the butt. So I still use the GraphViz record shape because it's kind of convenient, and they have this concept of ports in the record shape, and then I realized in my little graph creator here for the AST, the record shape. And it still works, but their documentation says you should prefer the HTML formatter over the record one. And I've used the HTML formatter, and it does work, but it also has its own unique set of peculiarities to it. So for simple stuff, I'm lazy. I tend to prefer the record layout. Yeah, exactly. Yes, it's very, it's like a DS. It's more of a DSL that has similarities to HTML than actually being HTML. in their documentation. Okay, that looks good. Just do the same thing with directive. Okay, so I fixed annotations. Let's keep saying annotation. So this is now rendering its parts like it should be. Okay, let's make blocks. Look at that. So pretty. It's pretty. Okay. review these. So I added an error, expected expression. So in the parse method in the parser, when we're parsing statements, we're expecting an expression, and if that returns null, then we issue an error there. In the dot model, I had made a boo-boo. So I meant to add this. I wanted to pre-allocate this string, so it was big enough when I go through and handle the escape characters for GraphViz, because I didn't want this loop to constantly be reallocating. And I had used resize instead of reserve. Oops. So fix that. And then in parser, this is where I had refactored to handle this condition here. And then I also remembered a particular use case issue with the ENTT framework. And this is really it's not its fault. It's just something I forgot. I was taking a reference to the component that was created here, and I was trying to modify it down here. The problem is that the expression call will most likely create other entities in the ECS, and if those are sufficient enough to cause the ECS to restructure things internally, this reference would no longer be valid. So the right thing to do there is not to carry references or pointers across blocks where you could be also changing the ECS. It's just to regrab the reference to that component when you need it. So I just fixed that. And then instead of explicitly popping after here, I do a defer, because if we have an error, I want to make sure we clean up the parent stack here in this case. So if the expression we get back is null, we issue that error message that I added. So that just kind of tightens that loop up a little bit more. And then in the AST module, this is my code that creates the GraphViz model based on our AST. So I refactored some stuff here from yesterday, just kind of cleaning things up. And as I was saying earlier, writing a compiler. So the record shape in GraphViz has what are called ports, and ports are created with pipe symbols and curly brackets. So you can create columns essentially and rows, so a primitive table more or less. And I was hard coding the structure to the left. I was just creating a string, which wasn't very flexible because individual nodes need to be able to kind of adjust what ports get created for each case. So I turned this into a string array, and then I just can then drop the different parts into the string array. And then the other thing I'm doing now is that each unique AST node type is setting a color, just so I can kind of quickly see. It makes the graph a little bit easier to navigate, at least for me. So the colors are being set. I also fixed directive and annotation so that they get their respective component off that entity and then graph the relationships there. And of course, there's a bunch of entity types, or not entity types, AST node types I'm not handling yet. A lot of these are keywords at this point. And then at the end of this function, which creates the node and any of the edges for it, we create a memory buffer, we loop over our port array, we format those correctly into the memory buffer so that GraphViz can interpret it, and then we just set the label attribute on that node, and that's working now. After I fixed my resize versus reserve bug. So I would say our AST formatter is pretty close. There's a couple things I want to put in here, but I'm going to commit this. So in the old formatter, I showed some of the detail around like number literals. So I think that would be handy to have. So in the case here, then, I think what that means is we add some new ports here. So for let's see, I can't remember. Yeah, so I can't. You gotta cheat, of course. Oh, yeah. What name did you come up with? Let's see here. Intra-thread memory ordering. These operations seem transparent. Okay. Acquire release, sequentially consistent. Strong sequence points are defined. Sequence points that affect the implementation. Machine. I like it. It's very clear. Yeah. Very nice. No, I mean it read very clean. I didn't see anything that seemed confusing. It very clearly broke out the two usage scenarios, I thought. Um, yeah, nothing. I probably look at it again later, but nothing immediately jumped out at me. Number size. let's see what that looks like. Yeah, it's not creating a new row. So I probably screwed something up. Oh, I know why. See if that fixes that. There we go. Better. Hey, Move. How's it going? Okay, so there's a couple more in here. Number type. So now we got all the metadata here on our number tokens. So that's helpful to have. So we know what type it is, radix size, whether it's signed, if it's floating point, whether or not it's imaginary. So I fixed an issue. So originally this code, it came from the old compiler. I refactored it a little bit. The way I was using this in the old compiler is the structure of the shape. That code was independent of the parameters that were going into the ports. So when I was escaping strings, the escaping was limited to everything that wasn't the structure of the textual description of the ports in the record. But this is different now because now I'm passing label in, it has everything in it. So my escaper has to be a little bit more intelligent. So I have to treat some of the formatting characters, like if I have an escape in the string for those, treat them as they are. Otherwise, escape them so they are the literal string. So it's a little bit different than what I had. And then for the number token, I'm just grabbing, or the number literal, sorry, rather. I'm grabbing the number token, which we create during lexing, grabbing that component off the token entity, and then I'm creating a bunch of extra ports for this node so that we can see all the details about the number literal. Because most of them live on that component on the token. So, and we don't duplicate it in the AST. There's really no reason to. Oops. Okay, so that's good. So now, let me bring up the AST here. So one thing we can do, the scope has a map on it, has a try map on it. Of all the identifiers that are declared in that scope. So what we could do is we could graph like dotted lines to the identifiers that are defined in that scope. This would be kind of similar to what I had in the code DOM rendering previously. So that's one thing we could do. The other issue, which I knew this was going to be a decision I would have to make because this existed in the old compiler as well. And I think actually we maybe even somebody in chat, I think maybe Phil made some comment about commas. Commas suck. And the reason is because they're overloaded in the language, and not just my language. They're overloaded in a lot of languages, and they subtly need to be interpreted differently. They need to be interpreted in subtly different ways in different contexts. So here I have two side-by-side examples of this. So first, let's take a look at the parser test just so we can see the textual code that we're talking about. So the first scenario is multiple assignment. On the left-hand side, we have A, comma B, comma C is being assigned 3, 4, 2. So if we go back to the PDF, that is this one here. So what's happening is right now the comma operator has a higher precedence than everything else. And the so what happens is the comma operator is breaking things up and then containing those pieces as a binary operator. So the very outermost comma on the left hand side is 2, and then we have that there's another comma that has 4, and there's another comma then that has the inner part, right, which is kind of weird, right? So what is showing here is that when we go through this list, we ultimately get to this inner node where C is being assigned to 3, but then there's these other identifiers and values that are hanging off the edge of that they're not really related to each other the way you would expect because of the precedence. So again, what's happening here is C assigned 3 is being, this is one binary operator, which is correct. But then what's happening is the comma operator is also grabbing A and B and 4 and 2 and kind of hanging them off the edge of that. Now, that's not, it's weird, but it's not impenetrable, meaning that the compiler can walk this tree and it can figure out what's going on, right? Like the left-hand side is on the left-hand side and the right-hand side is on the right-hand side. So we could figure it out, but it just, the structure here is not what you would expect. Now, the other scenario is where you say assign 1 to A, assign 2 to B, assign 3 to C, and these are comma separated expressions. The way that the parser is configured right now, that works correctly. So we have a comma that has a left, which has a comma, which has an assignment. A is equal to 1. On the right has B is equal to 2. And on the right of the parent, C is equal to 3. So in this particular scenario, the assignments are being grouped properly because of the priorities of these operators. And you can change it such that the priority of the comma operator works correctly in this case, but not this case, and vice versa. But getting it to work in both is not quite so easy. Now, what I did in the old, or there's actually two ways to look at this problem. You could look at this as the comma as the issue, or you could look at this as assignment is the issue. Either operator could be at fault, depending on how you look at this. The way I solved this in the old parser is I cheated. And what do I mean by that? What I mean by that is the right-hand side case, this case over here, this only appears in one particular syntactical context, and that is, multiple return values is, I definitely want that in the language. And just to clarify, it syntactically looks like multiple return values, but technically it's a tuple, so it's destructuring. But from the programmer's perspective, they get multiple return values. And that, again, syntactically, within a procedure, it appears that way, and from the caller, it appears that way. At the ABI level, there's always a single return value. So it's, from an ABI perspective, it's consistent, right, with everything else that's out there. But the compiler takes care of the other parts. So, yeah, what was I saying? Oh, yeah. So, this particular scenario where you do this, because unlike C, this particular syntax here on just a statement line is not intended to be valid. These need to be semicolon separated, but within a procedure definition, this is valid, right? Because you can define default values. And so not only a procedure, essentially inside of parentheses, this is valid, because for tuple syntax, for procedure call and procedure definition syntax, like this particular model is valid. Outside of that, it's not intended to be valid. Honestly, I don't remember if the old compiler actually asserted that case. It should have. So what I did in the old compiler is, in the lexer, I actually kept track of whether or not we were inside of a parenthesis group. And if we were, then yeah. Well, actually, I did it the other way. So in the old compiler, I treated comma as an operator, and it had a high precedence. And what I did was I changed the assignment operator token type. So in this particular case, this is not an assignment. It was a key value pair operator. And what that did was that allowed me, I have two different operators. Now I can change the precedence of them. But likewise, we could change the interpretation of comma, right? So essentially, comma inside of a parameter list, like Phil mentioned, we would just prevent it from triggering as an operator. In this case, we could then, so what we could do is we could configure the comma operator to behave correctly in this scenario, and then in the parameter list or initializer list scenario, it would just be something that we parse as grammatical structure. So we would always prefix or token check essentially the comma in those cases, and we would not treat it as an operator. So yeah, I basically have to pick one. The one issue, though, and I kind of remember this as being an issue, is that if we decide to make the this the operator case for comma, then that means that the binding power for the comma operator needs to be greater than the assignment operators. The problem then is in now the assignment, or I'm sorry, now the precedence of the comma operator is in between our assignment operators and other operators. And so in the parameter list, initializer list type scenario, then we have a problem, because to avoid the comma operator, what we would do is we would just call expression with a binding power that is greater than the comma operator's binding power. But the comma operator would be greater than the assignment operators, which we want to catch. So this was the other issue that I ran into. And this is an issue specifically because in Basecode, I want to support multiple assignment, and C and C++ and most other languages, like with the exception of Go, do not support that, right? So you don't, comma never enters into the equation in those other languages at the statement level. It just doesn't work that way. So they sidestep the issue. So, I don't know. My options are recognize that this kind of case can happen and write a function in the parser that fixes it, right? So essentially, we could have a little check that, hey, did we just get an expression that has a comma separator operator as the parent? Okay, if it does, let's recurse down, see if there's an assignment somewhere nested in there with leaf nodes that are not, that are identifiers or other expressions. And if they are, then let's just rotate the tree such that it looks right. Because we know what we want to do here to make this look correct. Yeah, essentially what would happen is this gets hoisted, right? So we would hoist the assignment, we would rotate the left-hand side down to the left-hand side of this, right? So this comma operator goes over here to push the left-hand side part of the tree down, and then these get rotated down to the right-hand side of the assignment. And then the default case, which just works, is the case that would exist inside of a tuple or parameter list or an initializer. We don't have to do anything special with these. We would still have to check, right? But we could tell that these would be the correct structure. What sucks about that is that, we actually have to tweak the tree, but what does that really mean in this case, right? So keep in mind that each one of these blocks is an entity, and in the case of binary operator, there is a component on that entity called binary operator T, and that has a left-hand side and a right-hand side field on it, which are just entity numbers. So there's just 32-bit integers. So those represent the edges between these. So essentially what we're talking about is grabbing components off these entities and just swapping edge numbers, right? We're swapping left-hand, right-hand side numbers to rebalance the tree, essentially. So that's correct. So from a performance standpoint, it's not horrible. And we could do that. We don't have to do that in line, right? We could do that as just so we generate the AST and then we go through as a pass and correct some of these degenerates so that they match the structure we expect. So that's one option. Another option is we could add context to the lexer. I'm not super excited about that, but it's not difficult, right? We would have to extend our lexer logic a little bit. So for like open parenthesis, close parenthesis, we would have to have some extra metadata, right, that tells the lexer, hey, keep track of these, like keep track of when we're in this state, and then expose, we could expose that as some kind of flag. And then when we parse certain other tokens, right, so then in the metadata for like the assignment operator, we could just have a thing that says, hey, if we're in this state, it's this. If we're in this other state, it's that. So it would all still be data driven, but it introduces context to the lexer. I mean, there's no doubt that that's a downside to it. And like I say, that's what I did. No, I probably wouldn't do commas. I would do assignments. They'd be different assignment operators, honestly. And then the comma would just always be a high precedence operator. It would always do the same thing. Because it's really the difference of behavior is how assignment should bind. In both of these cases, that's really where the issue is. It's not comma. The comma operator is doing exactly what it's supposed to do. It's just that the assignment operator it has two different left and right binding powers depending on where it's being used. So, yeah, but with all that said, I really don't want to do it the way I did it last time. I don't want to add context to the lexer. The lexer is beautiful the way it is right now. It's context free. It's super fast. It really is not storing any state, barely any state. Essentially, all the state that it has is on the call stack, which is nice. So, yeah, I'm kind of not. I'm heavily leaning away from that option. The other option is that I could use different syntax, right? I don't like that. I really want everything to be kind of consistent. But this starts to show you why you wonder why languages end up with different syntax for different things, or different syntax for similar things. Well, this is why it happens. So in the right-hand case here, right, where we're essentially defining key value pairs, we could use the equal, greater than, the arrow operator, the fat arrow operator, whatever you want to call it, to do these instead of assignment. But again, linguistically, that's kind of strange. That's not really yeah, it's kind of strange. Plus, we have two cases there. We have both the bind operator and the assignment operator, which are both valid. So then you would have to have alternates for both. Don't like that either. Yeah, so I think where that's taking us is fix the model. Fix the model in the degenerate case. I think we know how to find that, right? Because in this case, what we're looking for is a leaf binary assignment or bind operator on the right-hand side in the tree. Here's the problem, though. Yes, like I could parse the comma in the argument loop or in the tuple or whatever. That's easy. The issue is, though, is then how do I do that in statements? How do I do that at the statement level, right? So how do you do... The case is this one. This is the problem, right? Because you could say, oh, okay, well, those are identifiers, so, and those are number literals, but that's not the only scenario. This is, you could do, something like this. I actually don't even really need the parentheses. So hold on here. Right. So, so the problem is that there's a complex set of expressions that can appear on the left, and there's a complex set of expressions that can appear on the right. So the problem is at this level, the comma really has to be an operator because that's what it is. And then the key is, okay, well, if we make it an operator here, then inside of other special contexts in the parser, then we have to then be able to disable that operator because we don't want that operator to function anymore in that custom context because when I manually parse it. So these were the now I'm saying all this, obviously, like, this can be done. It's not an issue of can it be done. Like, there's plenty of parsers out there that do this, but they do it by just treating each case as a custom case, right? So in a standard, like, recursive descent in a standard recursive descent parser, you could just have explicit cases for all of this, which when I've looked at other languages that do support this syntax, that's what they do, right? Where this gets a little tricky is because I'm using a Pratt model, right? And the Pratt model has, again, there's an overriding operator model, and then within that operator model, you can do custom recursive descent parsing. But the Pratt model does kind of sort of want to push you towards making the comma an operator. You don't have to. I could specialize it, right? So if I did that, like let's say we just completely do not make comma an operator at all, and it's just a custom thing that has to be handled. So how would we do that? Well, I think the only way we could really do that generally and make it work right is in the expression loop, we would have to treat comma as a special prefix case. Apart from, so we would do a prefix parse, right? We'd parse this identifier or whatever this is, right? Variable declaration, whatever. And then after we do that, before we start parsing for left-hand infix operators, we would check to see if there's a comma token in the stream. And if there is, we would loop back. We'd go to the next token, and we would loop back and do another prefix parse. And we would keep doing that until we no longer see a comma. And then, of course, as we're doing that, we'd keep a list, right, of the expressions that we're getting that are comma separated. And then, of course, once there's no more comma, then the regular rules could kick off. And so what you would end up with is some comma separated thing assigned to some comma separated thing. And then this would work too if we did it that way. We wouldn't have to do anything special here either because, well, let me take that back. No, sorry. We wouldn't have to do anything special because then in parameterless, right, it'd be the same thing. You'd call expression to parse. It would get an assignment. It would then see a comma. Comma's not an operator, so it doesn't trigger the operator case. But it does see that comma is this list separator. So then it would go back to, well, actually, let me restate that. So this would be a prefix parse. There's no comma here. So then we would go into our standard infix mode. This is going to then parse the one. And yeah, so that's the only thing we would have to be careful of is like the comma operator can only apply at the top level. Yeah, it's because in the left binding case, like, so we would be in this, we would call parse or call expression potentially recursively. And we would not, in that case, want to consume this. The only other question on that approach is what would that look like, I guess, from a AST perspective? Like, what node is it creating here? So we could have a unique node type, I guess, that would be expression list or something, and it could create that. And then these would just be ordered children of that node. So you'd have an expression list node, an assignment to an expression list node, and then this would be an expression list node that has a bunch of assignments in it. Added complexity for me, the compiler writer. I mean, yeah, it's a little bit of a pain, but I mean, I can solve the problem. But I mean, for someone writing Basecode, you know, I personally want a language that supports multiple return values. I think that's a valuable syntactical construct. At that point, if we differ in opinion, then we differ in opinion, right? But I don't view that as a negative. If I wanted C or I wanted C++, then that's what I would use, right? Well, you can explicitly declare a tuple if you want, and then if you want to just receive a tuple and view it as destructuring, you can do it that way. But the destructuring syntax looks the same. So I just thought of something, maybe, that might work. So one idea that occurs to me that I could do entirely in the parser, so the Lexer would stay context free, and the parser so right now parent is a stack, which I actually should rename here because I am not being consistent. So parents is a stack, and the way that I'm using it right now is I'm just pushing and popping things off of it directly. But what I could do is I could wrap it in a method that yeah, so what I was thinking is we could change the binding power of the comma operator depending on what parent is on the top of the stack. So if it's a statement, we could change the binding power of the comma to be higher than, or lower, depending on which way you look at it, lower, so that it works the way that we intend it to work in statements. But if we are in a procedure or a call or a tuple or an initializer list, right, then we could change the binding power so it works the way we would expect in that case. That's one of the nice things, I guess, about the way this is implemented. This is all metadata. It's not hard-coded. These are just initial values or default values. So we could make those adjustments whenever we push a parent onto the parent stack or pop a parent off. Because we are pushing the statement before we run the expression. And then, of course, if the expression recursively defines things that are parents of other things, then they would push, themselves onto the stack as well. So that could work. Yes, this is C++. You know, Stunt said something that is making me think here. I wonder. Oops. It's a program called Dot, which is part of GraphViz. So yesterday I worked on a little library that allows me to create a model of a graph and then serialize it out to a dot file, which is just a text file. And then the dot program interprets that and then generates a PDF. And it can generate various kinds of output. It doesn't have to be a PDF, but I don't know. I find that convenient to use. closer. Closer. Yeah, so if I treat the comma operator as right binding, I can get it closer to correct in both cases. It's still a little off, but not too bad. It doesn't really impact. Well, actually, if anything, making it right binding makes this tree look a little bit nicer just from an ordering perspective. But it does kind of clean up a little bit. I make it smaller here. But I'm also thinking about something that Stunt mentioned, which is making me think. It triggered a series of thoughts about maybe part of the issue is I'm treating comma as a binary operator, or stated a different way, it's creating a binary operator in the tree, which is kind of part of the problem. Like, comma doesn't have to. It could coalesce instead of making new, you know? So then, the way I'm thinking about it, well, see, that's the weird part, right? So, like, the comma, if it's right binding or right associative, see, that's the issue here, right? Is that here, what we really want is we want the comma to claim the identifier here. And then likewise on the right hand side, we want it to claim the value. And actually, if we could get that to work right, that would be correct in both cases. So essentially what we want is we want the binary operator, or we want the comma to be always the left-hand side of the assignment and the right-hand side, if applicable. Because that's okay, right? Like, if I have assignment and then I have a tree of things on either side, that's fine. I'm cool with that. Right? That works. Huh, that's kind of weird though. So by changing the precedence here, right, that's exactly what I get. I get an assignment that has a tree of things on the left and an assignment that has a tree of things on the right. But over here, yeah. And then these get swapped because they're, yeah. I actually heard that song this morning. Gotta love Sirius XM. Okay, so now I'm thinking about this idea here. Actually, I need to take a short break. I gotta say goodbye to my daughter here. I'll be right back. Okay, I'm back. Okay, it's so weird. Like, I swear, my cache just completely dumped. And, so for comma, maybe I'm thinking about this the wrong way, which would not be surprising. mine's not working? That's not gonna work. Sorry, my brain's not working too well today. So here's what I'm contemplating. I'm thinking, okay, the special case we want is if it's a comma, we want the comma to accept any right expression but if it's an assignment, okay, here's what we want to do. First, we want to get the node component for the left-hand side that's passed into comma, right? So we have a comma, so A, B, C. 1, 2, 3. So we're going to parse A prefix. That's going to create an identifier. That's the left-hand side at this point. We're going to hit the comma in our expression, and that's going to cause this to trigger. The default behavior of this of infix is to create a binary operator. Right, so this was the left-hand side, but this would be, the right-hand side would be another comma, or another binary expression. But what I want to do is I want to coalesce this so it ends up as one node. So instead of generating new nodes, we're going to keep collapsing this into one node. So what's going to happen is we're going to prefix A, we're going to infix comma. Comma is going to look at A and it's going to say, oh, you're not a group. I'm going to make a group and I'm going to make you a child and I'm going to make whatever I parse next a child, which that's going to recurse. And so then the left-hand side would be so we're going to grab the node component of this. We're going to ask it if it is an expression group. That's what I called it, right? I thought. Node type. So if it's already an expression group, then we're going to grab the group component, So comma is going to get invoked. We're going to look at the left-hand side that's passed in. If it's already an expression group, then we're just going to keep adding the right-hand side to it. And we just keep returning ourselves because we've already been coalesced into a group. Otherwise, we're going to create the expression group, add the expression group component. We're going to parse. Problem with this though. Okay, so it's not a group. Yeah, so we have to do the trickery here. Because it has to be when we get here, it has to be a group already. Okay, so we're going to have a special case in our loop here. Oh, but Okay. So inside the expression function, what was this thing complaining about? If the next rule we're about to invoke in an infix way is for a comma, we're going to grab whatever the current left-hand side is. If it isn't an expression group, we're going to convert it into an expression group, adding what we were before to that expression group. That will now become the new input to the comma infix operator. And the comma infix operator is always expecting an expression group. And so then what it does is it parses to the right-hand side, except I believe it's Menlo. Hold on. Yeah, it's Menlo, which I think is a Mac font. I don't see it that often on other systems, but it might be available. So before we recurse, the current token is what we're about to parse. So if what we're about to parse is an assignment or a bind, we're done. We're not going to recurse anymore. Let's see how my crazy idea. Gotta love my crazy ideas. Well, it didn't blow up. Let's see what we got. Looks different. All right. So let's zoom in here. Oh, I'm not rendering. I put it in here and I didn't do it. It's closer to the block. Okay. Yeah, it helps when I create that part of the graph. Okay, so first, let me just verify standard binary operators look correct, and they do. So that's fine. All right, so yeah, shit, it's still not working the way I want. Oh, but wait, I forgot something. Because now it doesn't need to have that higher precedence working the way that I'm wanting it to work. So I've got to change that. Yes. Ka-ching. Almost, maybe. Okay, so this is exactly what I expect. So we have an assignment on the left-hand side. We have a group, ABC. On the right, we have a group, 342. But this one's fucked up. Because actually, yeah, it's a little weird. Okay, so let me think about that. It's close. So, just for clarification, what I'm expecting over here is an expression group. So there should be an expression group here that has A is equal to 1, B is equal to 2, whatever. So then these would be nested underneath the expression group. But what's happening is in assignment, so yeah. So assignment and bind, we'll just do assignment first. So we almost want exactly what we have with just a little tweak. So we want the inverse. So if it's an assignment, we don't want it to greedily absorb commas. We want it to skip them. So is that going to work though? It tells me that's not going to work. Well, we didn't get a parse error, so we didn't end up in a bad state. So that's maybe okay. Nah, it's just messed up. Sometimes you just gotta throw shit away. So I'm going to try the precedence adjustment by parent approach. So try the other thing. That was kind of stupid. It didn't work. So what we're going to do here is helps if I actually push it. Let's see what that does. Kaboom. Oh, right, because I'm calling it at the very end. That didn't work. So, comma operator 10. It's not a statement. Right, that's a block. Okay. So the statement's done. So now we're going to push another statement. Statement's done. I mean, it's doing the right thing. Doesn't. I might have. There's our comma. And it's got the right binding power. Huh? Yeah, the assignment's 20, 25, 20. So well, okay, actually, so the second case is not going to work because it needs to be in a different, it's in a statement, right? So this is currently in a statement context, so it's not going to work the way I'm doing this. I'd have to add in like something else to wrap it in a different context, but this one should be fine. But it isn't. Oh, wait. No, I'm just losing my head. Actually, never mind. This is correct. Okay, so we have equals at a statement level. On the left-hand side, we have the list of identifiers. On the right-hand side, we have the expressions. Okay, so this one's correct. This one's broken because we don't have, it's not in a different context right now. So then what I would need to do is like get the proc expression working, or like a tuple expression or something, so we could wrap that inside of that. Because those would push themselves right there as a new parent. So then we would end up in this alternate case where the binding power changes. So yeah, that's not too bad. I mean, compared to some of the other attempts I made, I'm not disliking that. It's all in the parser. We're not changing the lexer at all. That making it right binding is right because it fixes the order of the values so they appear in the right order. So that's correct. So yeah, I think this approach is the least intrusive. It works. But now I would have to detect this as an error, which is easy to detect, right? Parsing. So then this is a little expensive doing it this way. Is there a nicer way to do this? So now I'm wondering if I could just logically, this is always a statement context. So we could just change the precedence here, just reset it. And then anywhere else, we could just change it as needed. Like, we don't have to pay the price of doing this every time we push something on or take it off. Because anytime we go back into a statement context, right, we just reset. So actually, yeah. Simple is best. There. So now we have a helper method that little parser functions can call to change it. So really the default binding power should probably just be 25, although it doesn't really matter since we're changing it anyway. But yeah. ABC 342. Okay. Yeah, I think that is probably my best approach for now. And that gives me control in all sorts of different, like if I have to change it even beyond those two scenarios that we're looking at, it allows me to do that. Okay, so now let's detect that other condition. Okay, but what we want to do is we want to check for this degenerate case at the statement level, right? Or I should just say at any level. Right? So if yeah, so the check is actually pretty easy. We parse the right-hand side of the expression, and if that right-hand side ends up as another assignment, that's wrong. And that's what happens in the degenerate case on the statement level. So that's the condition we're looking for. And since I created my assignment helper now, which I wanted to do, so now is a good time to do that. better. All right. So what should actually happen is the parser should barf, give us an error message on that last line because it's not valid. And now the previous line, which is valid in context, oh no. Ooh. If we don't get anything back. Oh, right, it's unwrapping. That's why. Yeah. Unwinding. Yeah. So, yeah, it's recursing all the way down, and then this one's failing. But that's, it's okay. It's catching it. All right. So this case, we have to wait until we can get a little bit more of the parsing going to really verify that that's working correctly. Good. All right. So now we actually have our assignment operator that's distinct. And then we have our list on the left. We have our list on the right. They're in the right order. Good. I'm okay with that. Okay, so let's review that. Okay, so I added a new error, invalid assignment expression, and defined what that error looks like. I updated the assignment operator. I thought originally this was going to have like a list of entities in it, but We just have a tree, which we can deal with that. That's piece cake. I just added a constructor because it's a little bit more efficient to emplace these things through the constructor. And then in our parser, we have a helper function now, comma binding power, defaults to 25, which is correct for the statement context. I also added a field to track the comma rule, so we have a pointer to it, so we don't have to keep looking it up over and over again. And then I added the helper, the rule creation helper that I wanted to create for assignments, because I wanted the assignments to be distinct. They are binary operators, but I think it's going to be more convenient as we're doing code translation to actually just kind of have those be distinct on their own. I think that was pretty much it. And then so I renamed parent to parents. I put the stack code back the way it was because it was a little bit expensive to constantly be trying to change things when this parent stack changes. We have very specific points in the flow where we can change the comma binding power. So when we're parsing statements, right, we just reset it to 25. When we're in a context where it needs to be different, we'll just set it using that helper method. And so now all the assignments use the assignment rule generator, and lambda and associative operator they are not assignments. They were kind of grouped in there, but they're not assignments. So those just stay as infix right rules. We just assign our field or comma rule pointer to the rule that we get back, again, so we don't have to constantly look it up. And comma binding power just assigns whatever you pass in. And then the assignment rule, it's an infix that does right associativity. So we subtract 1 from the left binding power that's defined in the rule. And then what we're doing now is we're creating the assignment operator node. We look for our right-hand side expression. If that's null, we bail. Otherwise, we check, right? So if somehow we got another assignment as our right-hand side, that's not right. So we throw an error here if that's the case. Otherwise, we create our assignment operator component, which has the left and right-hand side of the assignment, and we return that node. And then our tests, don't do that. In our tests, that last case is now a parser error that's not valid in that context. It's valid in other contexts, which we'll test when we get to that. But at the statement level, it's not valid. So the only thing you can do with commas at the statement level is, so the left-hand side is kind of like C, the way like C or C might interpret commas at the statement level. I'm not supporting that. The only way you can use commas is on the left and right side of an assignment for the purposes of multiple assignment. If you want to do the left-hand side, then you just use semicolons, right? And it'll essentially be the same thing. It'll be all in one line with semicolons. And yeah, so that's good. Okay, I am going to wrap up a little early today because I cannot hear out of my right ear. It's driving me nuts. And so I have to go to the doctor and have them look at that. So I should be back tomorrow at my usual time. Thanks everybody for dropping by. Have a good one, and I will see you when I'm online next. Bye.